properties that I want to investigate is what we call odd functions or even functions. And you need a definition of each of those, so let's write these in. An odd function can be defined in two ways. First of all, has rotational symmetry around the origin. That means that if you have a drawing of a function and you have kind of like to put a pin in it where it crosses the origin, an odd function can only work. That's not true, I'll take this back. Doesn't always work. But often the kind of functions we're looking at the moment, it will cross through the origin. You put a pin at the origin, spin it around 180 degrees, just to look exactly the same. That's an odd function. And in terms of its notation, algebraic form, we would say that if f of x equals negative f of negative x. Now I'm going to get to what that means in a minute. Okay. An even function has line symmetry at the y-axis, or where f of x equals f of negative x. Okay, so let's have a look at what I mean by those two things. So we've got graphical and we've got notation definitions. Let's look at those notation definitions. I want to take a function that I know is symmetrical about the y-axis. Again, what I mean by that is if you kind of flipped it as a mirror image of itself, it will still look the same if we flipped it across the y-axis. So let's have a look at y equals x squared. F of x, let's write like that. F of x equals x squared. If I were to draw a graph of y equals f of x, it looks like that, doesn't it? You know that. We know what a parameter looks like, a quadratic y equals x squared. So in this case, we're going to draw that. The function of f equals x squared is going to look like that. We can see that, yeah, it's got symmetry across the y-axis. It's exactly the same on both sides. Okay? Using this function notation, what it says is, well, what if I plug in negative x? What does that equal? Well, as we've seen before, it means we put in negative x wherever there was an x previously. So I'm just putting in here negative x. And what is negative x squared? Just x squared, isn't it? Okay, it's the same as just x squared, which we know was our original function. So when I substitute a negative x into the function, I actually get the same value.
What if it's a square number?
Yeah, so not everything's an odd. This is a test for things that are odd and even functions. Let's take another one over here. Let's say g of x equals x squared plus 3. Some not even square numbers. It doesn't work out. G of negative x is negative x squared plus 3. X squared plus 3. It still is the same. Let's take another one. H of x equals x squared plus 4x. H of negative x is negative x squared plus 4 lots of negative x equals x squared minus 4x. Not the same. Okay, so it is not the same as h of x. So some functions we can put in negative x and get you the same function as the original one. Up here was the same. Not all of them do. And so we use this as a test. Is it an even function? Is it symmetrical about the y-axis? And so we can either draw it and see if it's an even function, or we can do the test and see if it's an even function. Okay? Any questions on that? We do the same then for our odd function. I'm going to move this out of the way because... And so let's have a look at f of x equals x cubed. F of x is x cubed. What is f of negative x? Well, I'm just putting in negative x wherever there was an x previously, and that equals, so negative x cubed is negative of x cubed, okay? Which is negative of the function. I should put this other way around. It's a bit easier to recognise. Like that. F of negative x came out to be negative of the function. That is what the definition of an odd function is. To draw that, that's what x cubed looks like. What it means is that if I go this way to an x value, whatever it is, I'll call that x1, and that's my function of x1. If I go this way and go to negative x1, then down here is negative function of x1. Okay, that is the same distance below the y-axis as this was above the y-axis over here. When I go the same distance to the right and up, I go the same distance to the left and down, I get exactly the same. Okay, that's the symmetry. If I was to put a pin there and spin this around 180 degrees, it would look exactly the same. Does that make sense? Yeah. And so, we can try another one here. G of x equals negative 3x. G of negative x equals negative 3 negative x equals positive 3x, which is negative of g of x. Can you see how 3 of x is a negative of negative 3x? Like a double negative on it. Okay? That is an odd function. However, if I was to have a function that was negative 3x plus 1, and I put in negative x into here, negative 3 lots of negative x here plus 1 equals 3x plus 1, it is not the same as negative of that. And if I want to kind of look at that, what is negative of negative 3x plus 1? That's 3x minus 1. And you can see they're not the same. So that function is not an odd function. Because when I put in negative x, it didn't give me exactly the same as the negative of h of x. I'll be good with what I'm expressing here with odd and even functions. So there's two ways to look at it. The graphical, we look at it and see, is it rotational about here, or is it line symmetry about the y-axis, or we plug in a negative x and see what we come to. Some functions are odd functions, some functions are even functions. You can't be both. It's either odd or even, or neither. Some functions are just not. Okay, this one here, for example, would be neither odd nor even. Okay? Certainly can't be both, though.